Next, to find the traces. We already know the formula for the normal trace. Pn is equal to summation of v upon b into bracket 1 plus or minus 6e upon b. So we also know that v is equal to w minus u, and we take eccentricity as a e is equal to b by 6. So for 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 full reservoir condition, so normal trace at the toe is Pn is equal to Wb upon 1 plus 6a upon b. So we take here the value of v, w minus u upon b into 1 plus for the toe we take here positive, so e is equal to b by 6, so 6 b upon, we take here e is equal to b by 6, so 6p upon 6p. So simplifying this, 6p w minus u upon b into 6b and plus 1 2, so 2 into bracket w minus u upon b. So we put here the value of w and u, so Pn is equal to 2 upon b, w upon u and w minus u. So for w, half bh rho w minus half cbw h. We put here the value of w and value of u. So by simplifying this, we will get wh upon rho minus c. So for the full reservoir condition, normal trace at the toe is equal to Pn is equal to wh rho minus c. Also corresponding traces at the heel. We take here, so corresponding traces at the heel, we have Pn is equal to Vb upon 1 minus 6e upon b, because for heel we take here negative. So by putting here Pn is equal to Wu upon b into bracket 1, so 1 minus 1 minus 1 0, so whole term is 0. So the normal trace at the heel is equal to 0 for full reservoir condition. Next one, principal traces at the toe. Principal trace at the toe. So we know the formula, sigma 1 is equal to Pn sec square phi. So we put here the value of Pn, Wh rho minus c so Wh rho minus c into bracket for sec square phi we put here b upon h bracket square plus 1. We know that b upon h bracket square is equal to 1 upon rho minus c. 1 is equal to, we put here value wh rho minus c into bracket 1 upon rho minus c plus 1. So by simplifying this we get wh into rho minus c rho minus c rho minus c plus 1. Now the shear trace, then shear trace at toe. We know the formula toe is equal to p n tan phi. So we put here the value pn, value of pn wh rho minus c into tan phi b upon h. So b upon h, the value of b upon h is equal to 1 up b, value of b upon h bracket square is equal to 1 upon rho minus c. So value of b upon h is equal to the value of b upon h is equal to 1 upon under root of rho minus c. So toe is equal to wh into, so toe is equal to wh into under root of rho minus c. So the normal trace at the heel is 0. So normal trace at the heel is 0. Therefore the principal and the shear trace at heel will be 0. So second है reservoir empty condition. इसका मतलब है कि पानी नहीं होगा, no water will be there in the dam, so no force will be act among the water pressure, uplift pressure and the weight of the dam. Only the weight of the dam will be act. मतलब समझो कि डैम में पानी ही नहीं है तो फिर वाटर प्रेशर नहीं लगेगा और अपलिफ्ट प्रेशर भी नहीं लगेगा. सो ओनली weight of the dam act, weight act at m. So maximum compressive trace at heel is equal to, we know the formula v upon b into 1 plus 6e upon b. So in place of v we put only weight upon b to bracket 1 plus 6e upon b. So in place of e we put e is equal to b by 6. So here it's 1 w upon b into bracket 1 plus 1. So is equal to 2 W upon B. So maximum compressive stress at the heel in empty condition 2W upon B. So next, maximum compressive stress at the toe. We only put here negative. So W upon B, 1 minus 1, so 0 is equal to 0. So maximum compressive stress at the toe is equal to 0. So at the last, we summarize all the formulas. Stresses develop in the elementary profile. Normal stress Pn is equal to V upon B into 1 plus or minus 6C upon B. So V is equal to W upon U and E is equal to B by 6. So for full reservoir case, normal stress at the toe Pn is equal to WH rho Pn is equal to WH rho minus C, and for the normal stress at the heel Pn is equal to 0. So principal stresses at the toe, rho 1 is equal to WH rho minus C plus 1, and the principal stress at the heel will be the 0. So shear trace at the toe, toe is equal to WH under root of rho minus C, and the shear trace at the toe will be 0. So normal trace at the toe will be the Pn is equal to WH rho minus C, and the normal trace at the heel will be the 0. So reservoir empty condition, maximum compressive stress at the heel is equal to 2W upon B, and normal trace at the toe is equal to